So what we're looking at in this video is the area and perimeter formulas as it relates to math facts that people learn. So in math, we have arithmetic, statistics, geometry, trigonometry in the early stages of math learning in the K-12 space. And so over here, we're talking about area and perimeter of shapes. We're starting with squares and rectangles. With squares, if you want to find the perimeter, you basically multiply the side length. Let me just call that S. S represents side length. You multiply that by 4, and that tells you the perimeter of the square. A square has all 4 sides equal, right? That's part of its definition. All the sides are equal. And so if we have a square, we can add all 4 sides, or we can simply multiply by 4. So that's how we find the area of a square. The perimeter of a square. If we want to find the area, we actually say the side length squared. So whatever the side length is, you square it. So like 5, if that's the side length, you say 5 squared, and that's 25. This is called a rectangle. A rectangle has, in this case, right, we're looking at a shape that has 2 sets of sides that are equal, they're parallel, and they're equal. So in this particular case, we have the length. The value of the length will be the same top and bottom. The value of the width will be the same on the sides, right? So that's part of what's going on here with the rectangle. So we say 2 times length plus width, meaning that add the length and the width together, multiply that by 2, and now you have the area of the perimeter of the rectangle. In order to find the area of a rectangle, we simply multiply the length times the width. So that's how we find the area of this rectangle, is we would just multiply the length times the width. The area of this square, we just say side squared. That would tell us the area of the square. And the area is the inside of the shape, right? That's the area. The perimeter would be the values of the outside added. What is the real life implication of this? When you find the area of a shape, again, you're finding the details of the inside of that shape and looking at what is the, for example, you're trying to mow the lawn somewhere, and you need to know the amount of area you need to cover, and some people might do that and charge a certain price. Hey, if your lawn has a certain area, I will charge you this much because it takes me this much time. Now that brings in another factor, which is physics and finding the rate of change. We'll talk about that later in this quest of counting to calculus. So we have the area, the formulas have been defined for 2 plane geometric shapes. Example 1, we have the side length of this square is 5 centimeters. So the perimeter would just be 4 times the side length. That is 4 times 5, which is 20 centimeters, right? So 4 times 5 is 20. Notice that you're using your math facts from knowing how to multiply to do the problem. Number 2, before I go on to number 2, number 1, if I asked you what's the area of this shape, you would go back to the formula side squared. So then you would ask, what is 5 squared? 5 times 5, 25. Excellent. Example 2, if we have this rectangle that has length 7 centimeters for the length and 5 centimeters for the width, you multiply the 7 times 5 to get 35 centimeters squared if you're finding the area. But if you're finding the perimeter, you say P is equal to 2 into length plus width. Notice that I love writing the formula out again, and then I substitute the values in to find the answer to the problem. Note taking is a very important part of excelling in mathematics. So I really want to encourage students to take good notes, show your work every step of the way. And so here we have P is equal to 2 into length times width. Length times width is 7 plus 5, which is 12. We have 2 times 12, which is 24. That's the perimeter of this rectangle. How about if we have a shape that is not a traditional shape? We call this, in one sense, think of it like well, it's not fully complex, but it's like a complex shape, but more like a shape that has different components to it, right? Now, I've broken this down for you, but I could have given it to you without, this line here, and then you can figure it out on your own, right? But let's say we leave it like that, okay? We know that it has a square on top of a rectangle. If you want to find the perimeter, all you do is you literally add, starting wherever you want to start. And this is why it's important to know the commutative property of addition, because the order in which you add things doesn't matter. The order in which you add things doesn't matter. Now, the commutative property of addition is not necessarily applicable to every arithmetic operation. So what I mean by that is the order in which you divide things matters, right? 2 divided by 1 is not the same as 1 divided by 2. But 2 plus 1 is the same as 1 plus 2. That's called the commutative property of addition. There's a commutative property of addition, a commutative property of multiplication. Those are facts that we should remember, and they will help us in solving math problems efficiently. And so what we have going on here is that we're just going to add all the sides that we have available to us. So we have 5 plus 5 plus 5 plus 5 plus 10 plus 5 plus 5, and that will give us our answer. That would tell us the perimeter of the shape. So when you add up all those numbers, what do you get? Feel free to write that in the description or in the comment section if you want. But before I let you go, let me give you some, so we've talked about the concept of a geometry. Let me just leave you with some math history. Now, why would this be so important in the history of mathematics? Well, the Egyptians built the pyramids, right? You could technically find the volume of those pyramids, the surface area of those pyramids, and we'll get to surface area and volume later on in this journey of counting to calculus. But it's very important that you understand that this is used in everyday life. When you're laying down carpet, you need to know the area of the room that you're working with, right? When you're trying to find the line of a soccer field or football field, if you're trying to get how much paint should I put as I'm laying down the lines, that involves knowing the perimeter of the shape. As far as history goes, the Babylonians, the Egyptians, the Greeks, they were all involved in understanding astronomy in different ways and understanding geometry. Geometry and astronomy, very important groundwork that would lead us into the era of Isaac Newton and the scientific revolution when René Descartes does his work. But then even all the way to Einstein's theory of general relativity and trying to understand some of that, there is some things involved. They're not, it's called non-Euclidean geometry. But before you can understand non-Euclidean geometry, what is Euclidean geometry? What are parallel lines? What are perpendicular lines? We're going to explore that more in geometry. But get a copy of Euclid's book and have it handy. Save it as a PDF. There are free copies on the internet, and we'll talk more later. Thanks for watching this video. Feel free to like and share and subscribe to our channel where we talk about counting to calculus concepts, helping every student to master mathematics. So let's master more math. Have a blessed day.